Got my pen going. There we go. All right. So a couple things. I've been trying to get all your extra credit possibility points up and running. So I've added this one already here. You guys already seen the early morning problems. Hopefully you guys did yesterday and today. Yesterday's question, let's talk about it real quick. What does this represent and what does this equal to, right? Yeah, on Wednesday I uploaded it at 7. It was uploaded before, I just forgot to hit the publish button. So yeah, some people messaged me and I got it up. I think I hit the publish button at like 7:10 instead of 7 o'clock. So it took a little bit longer to show up. So I got to remember to hit publish when I save my work. So I save my work. I do this stuff at night and then I just forget to publish. It was late. It gave me a lot of anxiety. Sorry about that. Sorry about that. But hopefully you're able to get in there and do this problem. Right? Hopefully you're able to do this problem. So what I was looking for, right? What does this represent? Hopefully you guys are able to see that this is the limit definition of a derivative, right? That's all this is. It's f of x plus delta x minus f of x. Now you'll say, knock me, that's a 1. That's not f of x. All divided by delta x. And of course, it's the function being evaluated, and I hope you guys see that right there. There's no x there. There's a pi over 2, which means that it's taking the derivative. Oh, no. So that's what happened. Yeah. Sorry about that. But yeah, this one was it. The limit definition of a derivative evaluated at pi over 2. So you didn't actually have to try to solve this limit, which involves a lot of trig identities. Instead, you can just identify that, okay, f of x in this problem is sine. We're doing the limit definition of a derivative of f of x. So I just need to find the derivative of f of x. So derivative of sine is cosine. And then it's being evaluated at pi over 2. So all I have to do is plug in pi over 2. So that's it for this one. It's take the derivative. What the? Why is it still asking people to join? They should be on auto join. I hope they're able to join. But yeah, that's yesterday's, right? Yesterday was the limit definition of a derivative. That's all I was asking for. This is the limit definition of a derivative of the function f of x is equal to sine of x being evaluated at pi over 2. The answer for that would then be, of course, whatever cosine of pi over 2 is, which I believe is 0. If you actually try to do this limit, I think you end up with 0 over 0, which is not okay, right? So that was that one. Today, this morning, and it was a very easy one, very simple one. I just wanted you to name as many derivative rules as you can, right? There's the addition rule, subtraction rule, right? If you take the derivative of them, you just add them together. There's a product rule, quotient rule, right? Power rule, constant rule, coefficient rule. I just wanted to see how many you guys could name that we end up using quite often when we take derivatives of things. There's trig rules, right? For sine, cosine, tangent, all those ones. They're not actually rules. They're just like, those ones are just actually like the derivatives that you memorize. But yeah, all these rules that you can name. So that was that for today. I think today was available at 7. Yeah, I think today's was available at 7. You were able to type it in. All right. And that's that. Then you might see that this is now up and running. The Calcmedic and the Khan Academy are taking me a little bit more time, but for Khan Academy, you guys can start without doing this. You can just come after and show a type. I'll just have a page that says type the word complete so that you've completed each chapter. I'll get those up and running soon. It's just taking me a little bit longer to code those in there. For the My AP College Board, I've only been able to do up to day 3, but they're all up. They have a link to the video that you can watch on YouTube. I'm not going to sit there and double check that you've completely watched the video. I'm just going to trust you that you have, and then that you'll be working on these problems that go along with the video. Huh. All right, get out of here. So you can, they have these problems that they work along in the video, and then they leave a couple for you to do on your own, to try on your own. So yeah, there you go. Take a look at those, try them out. Each of them, each topic, whoops. Yeah, each topic have, each video is a different topic that's going to be covered on the AP exam. So day 1 was all on derivatives and the chain rule. Day 2 was applications of derivatives. And then for day 3, they decided to go into how to find limits and continuity. I remember that was a question that was asked quite a bit at the beginning of this class. How can you tell if a function is continuous or not? right? So that's there as well. So that's up and running. That's good to go, right? So is the daily one. So again, if you do the Khan Academy one, you can just watch the videos and work along without me assigning them. And then when I assign them, you should already have them completed. Same thing with the Calc Medic. That's already up and running and good to go. I should set up those pages soon, though, just in case there's a couple of you who are stragglers who did not sign up for Khan Academy or Calc Medic when I first introduced them. But yeah, there you go. That's that. All right. That being said, let's jump into today's lesson, where we left off last time. Right? We were talking about the integral as an accumulator, right? It basically can calculate how much something has accumulated over a set amount of time, right? So we talked about like a very simple one, which is like a printer that's printing at 8 pages per minute, right? If we graph that, we know that the integral is the area underneath the curve, which happens to be the same thing as how many total pages would be printed over a set amount of time, right? So this is what I was trying to say. Like, you have a rate of something. We always talk about miles per hour, and if you talk about how long they've traveled for, you can calculate how far they've traveled. It also works for rates of other things, like rates of anything you could think of. Like mine was how many pages a printer can print over time. The last example we were doing was how much snow is falling over time, right? So the rate at which snow is falling is given by this right here, right? This function f of t is the rate at which snow is falling onto a driveway, right? In cubic feet per hour. And then they also give us g of t, which is the rate at which Janet removes the snow from the driveway. So it's a rate at which snow is being pulled off or taken off of the driveway, right? So we got to go through these parts here. And I just wanted you to understand, like, this is one of the questions that was on the AP exam. This is a free response question that was on there. And for part A, this is all you had to do. This was a calculator part. You don't even have to do the antiderivatives by hand here. You just plug this into your calculator, right? Integral from 0 to 6 of f of t dt, but f of t was this function. All you have to do is plug it into the calculator. It would look something like this, right? 0 to 6 of 7t e to the cosine of t dt. This is literally what would have gotten you your point, this answer right here. See that? And all you have to do is plug it into the calculator. Now, here's the thing, though. Some people are going to get a different answer when you plug this in your calculator. One of two things could happen. First thing that could happen is that you plug this part in incorrectly, right? This whole function, actually. I'm just calling that as one whole thing. You could have plugged it in as, there's no t button on your calculator, so that confuses some students. You can just put it in as 7x e to the cosine of x dx, right? Because this is just a dummy variable on there. The second thing that could have gone wrong is that your calculator might have been in degrees. In AP Physics, if you're taking AP Physics, you usually have your scientific calculator working in degrees mode. For AP Calc, with integrals and derivatives, you have to have your calculator in radians. And that's because when we deal with things like trig functions, the chain rule is always being applied when you do derivatives and when you do integrals. Those chain rules only work when we're dealing with it in radians mode. So an important thing that you need to know, right, is when you're working with this and you're working on it with your calculator here, double check that your calculator is in radian mode, right? And when you come in to take the AP exam day of, make sure the calculator you have is in radian mode. Just because, by the way, the school is going to provide you with TI 84 calculators if you don't have one day of the exam. You can check one out. When you get there, let them know that you need a calculator. I'm working with Dr. Gogate to make sure that you will have access to one, just in case you haven't bought one yet, because these are expensive. And they are very, very necessary on the AP exam. Hopefully you've been practicing with your Chromebook, right? Because I gave you that free app, I gave you a link to that free app so you guys can be practicing this. But anyways, this is the first thing you need to check off. When you turn on your calculator, press mode. And right here on the third line, there's radian and degree. If you're doing the AP Physics test, make sure you're in degree. If you're doing the AP Calculus test, make sure you're in radians. Okay? Can't stress that enough. So that being said, all you have to do after that, we just plug this into math, go down to option 9 to do this integral on the calculator. Right there. Plug in the values for your integral from 0 to 6, and then plug in your function, 7t times e to the cosine of t from down here and put that to the power of the differential of x. There, press enter. It's going to evaluate it, and that's going to be your answer. Now, if I did the same thing, but it was in degrees, this is what would have happened. Boom. And you see, you won't be able to, it looks reasonable, like 300 cubic feet of snow. Nah, that's possible. You could have had a lot of snow. It could have been a heavy snowstorm. I don't know. But always double check what mode your calculator is in. It makes a difference. Okay? All right. That was that one. And then I was trying to get you guys to do these on your own, and then I was looking at them, and I realized, like, some of you might have actually. Some of you probably did, some of you were probably able to get these answers here, but it was kind of unfair for me to ask that without me showing you some examples. So let's take a look at this one right here. Let's take a look at part B. Some of you guys might have figured out part B, right? This one's asking to find the rate at which the volume of snow, find the rate of change of the volume of snow on the driveway at 8 a.m. Okay, so the rate of change is just asking the rate at which how much snow is falling minus the rate of which the snow is being taken away. That's it. And that's what we have here. F of t is the rate at which snow is falling, right? F of t is how much snow is falling on there. And I just need to take away the rate at which how much snow is being taken away on there. And that's it. It's F of t minus g of t. Now they want it at a specific time. They want it, right, at 8. So all we got to do then is plug in 8 in for t, right? Because that's how this model works, right? Midnight is 0, t equals 0. So 6 a.m. is t equals 6. 8 a.m. is t equals to 8. So all I had to do was plug this in as f of 8 minus g of 8. And you just plug this into your calculator, right? So f of 8 is this crazy function right here, 7 times 8 times e to the cosine of 8 minus g of 8. G of 8 is right here. T is equal to 8 is between 6 and 7, so g of 8 is going to equal to 125. That's it. And this is the calculator section. Plug it into your calculator because actually, yeah, you could plug it. You could, in theory, we could leave it like this. In theory. Actually, I believe you can just leave it like this if you can leave it, if you are too scared to type this into your calculator. Supposedly, you do not need to simplify it. If the grader can just plug this into a scientific calculator, you're good to go. But I'm going to finish this off just because I don't like looking at things like that. But if you're really, really lazy, I believe this is a full-on point. You can get full credit off of this, is what I've been told, is that you do not need to. Why is it that function? Which function? Monica, specified your question is why is which function which? Wouldn't it be the 108? Oh, you're right. Why'd I go between 6 and 7 when 8 is between 7 and 9? That's right. My fault. Okay. Good catch. Whew. Almost made that one. Okay. Sorry about that. All right. Anyways, let's plug this into our calculator. 7 times 8 times e to the cosine of 8. Boop. I get there. That is 448, right? And I'm going to subtract that answer with 108. And I get here negative 59.58. Negative 59.58. Is that okay? Can my rate be negative? Is that okay? Cubic feet per hour. What does that mean if my rate is negative? What is happening at 8 o'clock? Knowing that the rate is negative. Anyone got any ideas? I'll give you a second to type that in. I'm going to plug in my fan real quick. Hold on. All right. What does that mean when the rate of change is negative? What's happening here on this particular problem? More snow is being shoveled. More snow is being taken away than it is falling. That's it. That's all it's saying. The rate is negative means that we're losing snow, right, at this time. There's less snow. I mean, more snow is being taken away. I like that. I like that. That's it. That's all you got to figure out. It doesn't actually ask that question, but sometimes on the AP exam, they will ask stuff like that. Okay. All right, let's go to part C. Let H of T represent the total amount of snow in cubic feet that Janet has removed from the driveway at time T after midnight. So let H express a piecewise function with the domain T between 0 and 9, right? So how much snow is being removed, right? So they basically want something like this. They basically want something where H of T, right, is equal to, and then there's 3 functions here for the 3 different times, right? So when T is between 0 and 6, right? And then when 6 is less than T is less than 7, and then when 7 is less than T is less than or equal to 9, right? How do I get these right here? It's part of what's given. You see that? The amount of snow she's removing follows this piecewise function, which has these 3 different values. She's not removing any snow from 0 to 6. She's removing a rate of snow here and a rate of snow from here to here. How do I get those functions? How do I get those functions? Well, if G of T represents the rate at which snow is being removed by Janet, and I want H of T to show me the total amount of snow that's been removed, right? Then all I have to figure out is the integral of what we're dealing with, okay? Figure out the integral of what we're dealing with. Sorry, my back is a little itchy. Okay, so what you're going to do is the integral about 3 different times because we have about 3 different function values here. So check this out. Okay, so we know that at the beginning, at H equals 0, Janet hasn't removed any snow yet, right? So I'm going to go ahead and write that down there. Now for 0 less than or equal to T less than or equal to 6, right? H of T, hopefully you guys agree, is going to be equal to the integral from 0 to T of G of T dt plus H of 0. This is right here is usually like it's usually our constant that we're trying to find, but we can actually figure that out just by seeing this right here. Okay, so when I do this integral right here, G of T at between these values right here is just going to be equal to 0, right? So this right here is equal to the integral from 0 to T of 0 dt plus H of 0, which is 0. So when I evaluate this right here, the function right here is going to tell me that it's going to come out to be, well, the integral of 0 is just 0 from 0 to T. So this is equal to 0. So how much snow has she removed from 0 to 6? That function is 0 because she just hasn't started removing any snow yet, right? That kind of hopefully makes sense, okay? Hopefully it makes sense, hopefully. So we keep going then. We do the next one. The next one is for 0 less than, 6 less than T less than or equal to 7, right? That's for the next block that she's removing snow at. And she's removing snow at a rate of 125, right? So H of T in this case is going to equal to the integral from 0 to T of, same thing as GT at that point, which is going to be equal to 125 dt, right? Plus H of 6, all right? That's, wait, it shouldn't be from 0 to, it should be from 6 to T, I'm sorry. We don't do 0 to T because 0 to T is the initial part. We're doing it from 6 to 7, but T can be anywhere between that. So we're going to go from 6 to T. I messed up there. That should not be a 0. Now, it's only a 0 if that's where we're starting from. That's our starting point in this case. We're starting at 6. Okay? So when we do this integral right here, the integral of 125, right? I'm hoping you guys can see it. It's going to be 125 times T minus 125. We got to plug in these values here for T and 6. So it's technically this. It's technically 125 times T evaluated from 6 to T plus 0, because h of 6 is equal to 0 still, right? Because that's what that function was right there. Now, when you plug this in, this will be 125 times t minus 125 times 6. I'm going to read it. I'm going to leave it like this. Hopefully, you guys don't mind. And that's going to be it. The function from here to here, from 6 to 7, is going to be 125 times 6 times t minus 6. So hopefully, you guys don't mind seeing that. Here, I'll show all the way through. Let me show the work all the way through here. So just in case for some of you who get a little bit lost here, it's 125 times t, right? Minus 125 times 6. I just didn't want to multiply 125 times 6 because it's a very large number. So I just wrote it like this instead. But that's the general idea of it. So let's bring that out here. I'm factoring out the 125 and leaving behind the t minus 6. Just to make it so it's a little bit easier. So I'm doing the integral here with these different values here, right? How do I know that that's going to be from there to there? It's basically from where it starts, and t is any value between 6 and 7 for this part of it. And then you do it again for one last one, right? We do it again for one last one. 4, 7 less than t less than or equal to 9, right? We do the integral from 7 to t of the rate, which is 108 now because she's gotten a little bit tired, so the rate is not as fast. 108 dt, right? Plus h of 7. H of 7. So doing this integral, this is going to be 108. And if we follow the same pattern, this is going to be t minus 7, right? T minus 7 plus h of 7 in this case, though, is not 0. H of 7 in this case is, well, we have to plug in 7 into this function right here to see what it would be. So it would be 125 times 7 minus 6. That's what h of 7 is, right? Because we found out that one from the one before. So this is going to be equal to 108, right, times t minus 7 plus 7 minus 6 is 1 times 125. We get that right there. And this is my function of how much snow has been removed given a specific time. And that's my answer. It's a lot of work. A lot of work. Hopefully you guys can see that okay. It's not too small, right? Hopefully. All we're doing now is we're just applying our integral, right? And it looks like I'm applying integrals for random stuff here, but if you look at it piece by piece, it's the times that they're giving us, right? I need the integral from 0 to 6. I need the integral from 6 to 7. I need the integral from 7 to 9. But I don't actually plug in the final number of 9 or 7 or 6 even, right? I plug in this t as a placeholder so that the function I derive here, that I get here, I can plug in the t afterwards to see how much snow has been removed, right? This is a function that does that and sets it up for you. Right now, if they were asking how much snow had been removed at t equals 8, right? How much snow has been removed at t equals 8, then I would go and just plug in 8 into here. Now, if I didn't have this function, I could have just done the integral from 0 to 6, right? Plus the integral from 6 to 7, plus the integral from 7 to 8. And then you have to do 3 different integrals because there's 3 different functions there, right? But it's still g of t, but g of t has different values for these particular intervals. That's the idea of what's going on here. So we're just breaking it down so that we have it set up. That's what this question's asking for. Okay? All right. With that being said, let's go ahead and take a look at part D. How many cubic feet of snow are on the driveway at 9 a.m.? So for this one, right, how much snow has fallen in total by 9, right? So for us to do that, all we have to do is, well, how much snow has fallen? Total snow fallen would be the integral from when it started snowing, which is midnight, to 9 a.m. of the function of the rate at which snow is falling, so which is going to be f of t dt. That's going to tell me how much snow has fallen. I'm going to, of course, then take away the total snow removed. Removed. And the way we figure that out is going to be, well, we already have this function, don't we? we have the function right here. You could do the integral like I was trying to show you. This triple integral right here, do it from 0 to 6, 6 to 7, 7 to 9. Try to figure that out. Or realize the fact we just wrote a function that does that for us, right, at specific times. If I'm looking for the specific time at 9, I could just plug that in as h of 9. That's going to be it. Okay? So I have here, to calculate this last problem for part D, it would be from 0 to 9 of, what was my f function again? It was 7t e to the cosine of t. 7t times e to the cosine of t dt, minus h of 9, which is just going to be the function 108 times 9 minus 7 plus 125. And that's it. That will tell us how much snow there is. Plug this into the calculator, right? See what you get from 0 to 9, and then plug this into the calculator, subtract the 2. The answer you should get if you work this all the way out is, well, I actually don't know. Oh, by the way, if you're looking for stuff that you typed into in the past, oh, I closed it. Anyways, if you ever typed in something and you need to go back and just change a number, you can always hit second and enter, and it'll bring back the last thing you typed, and you could do that repeatedly. That's the last thing I have on there that's typed in there. Anyways, so math, option 9, integral from 0 to 9. The function is 7t e to the cosine of t, all with respect to t. You hear me saying t and it comes out as x's. Remember, those are just dummy variables that's on the calculator that you can switch out with each other. This, of course, is going to be subtracted from 108 times 7 minus 9 plus 125. So I get my answer there is 26.33. That's how much snow, right? 26.33 cubic feet. That's how much snow is left on the driveway. And there you go. So, yeah. I'll put a couple practice problems up for you guys. I'm trying to find some for you that you can try doing. It is a lot of work, but I think what I'm going to do is when I put these problems up, I'm just for time's sake, because we're cutting close to the end here, I'll give you the answers for them as well, so you can check your answers along the way, so you can see if you're doing them right or not. And if you see that you're not doing them right, I suggest you stop by office hours, and then we can take a look at them. Remember, my office hours has changed. I'm no longer from 1 to 2. It's now from 2 to 3, just so I can give myself some time to drive to school for after-school tutoring, which, by the way, someone has signed up. So if you guys want to show up today, you guys can. Please do. It is an extra couple hours on campus. And I have been recording down who has been coming to my my after-school tutoring and who has not been coming to my after-school tutoring. Just make it if you can. It's not mandatory. I just, want to see you guys. All right, that's that. And let's keep going. Moving on to the next stuff. Let's go. We're going to be going here. The title of this, if you've been titling your notes, this next one up, for applications of integrals, right? Applications of integrals is the main overall theme of this chapter. The title for this section of it is going to be finding areas between curves. I'll just go with that. Finding areas between curves. There we go. So you guys know, right, when we do the integral of a function, right, the integral of a function from a to b, let's see here. Let's give you guys a second to actually write this stuff down, but you don't have to write this part down, this next part. If we do the integral from a to b of a function f of x dx, right, graphically showing this, right, if f of x looks something like this, right, and let's say that a is here and b is here, right, what this essentially shows, this integral right here, all it's showing is this area right here, this area underneath the curve. Right, that's all an integral does. It finds the area underneath the curve for you, right? And if it was on the bottom side, it would just be a negative area, which we talked about, right? Which is the thing, okay? Well, here's the thing. We can modify this concept, and instead of looking for the region that's underneath the curve, right, that's between the curve and the x-axis, how about trying to find the area between two curves? So what would that look like? If I had two functions, right? So let's say I have two functions here. Let's say I have a function that looks something like this. Okay, let's call this f of x, right? And then I have another function that looks something like this. Let's call that g of x, right? And instead of finding the area underneath the curve, I wanted to find the area that's between the two curves. I want to find this area right here, right? I want to find this area right here. Now, how do I do this? Well, it's kind of like if you slowly think about it intuitively, some of you guys might actually come up with the right idea of how to figure this out, right? So check this out. You ready? If I were looking at, let's say, I don't know, at just f of x, right? If I was just doing the integral of f of x, right, and I was only looking at it from here to here, it would give me this total area right here, wouldn't it? Just for simplicity's sake, let's say these numbers right here where they cross, let's say this is 1, and then let's say this is 3, just for our sake right there. So this right here is still 1, this right here is still 3. How do I get this area right here that I have in orange right here? It's just the integral of f of x only, right? And I'm doing the integral from 1 to 3, okay? Doing the integral from 1 to 3. This is the area, right, of region under f of x, right? That's what we got here, right? Now, that's not what I want, though, right? I want the region between f and g. Anyone know where I'm going with this? Anyone have an idea what's happening? How do I do that? I want it between f of x and g of x. Well, if I only do f by itself, I get this whole thing in orange, don't I? Boop. Well, if I look at the integral, let's do this in red over here, from here to here of only g of x from 1 to 3, right? That's going to be this area right here. And I already see someone typing into the chat. Someone already sees it. Right? That's this area right here. And Kayla's saying, subtract the area under g of x from 1 to 3 from the orange part. That's pretty much it. That's pretty much the idea. Right? If I get this area that's under g, right here, and I subtract that from the area that's under the orange part, which is the area under f of x, that's going to give me this area over here in purple, isn't it? So if I just subtract these two right here, if I subtract the integral, I forgot the important elements of d of x here, right? If I, all right, dog. Rude. I'm in the middle of teaching class here. All right. My dog just burst in through the door. Okay, so if I do the integral from 1 to 3 of f of x dx minus the integral from 1 to 3 of g of x dx, that's going to give me this area right here, right? And then it's the integral from 1 to 3 of, you ready for this? F of x minus g of x dx. That right there is it. Now, how do you know which one's f of x and which one's g of x? In my mind, whenever I did this problem, I always used to call this the top function, right? And then this one right here, I call this the bottom function. It's the one on top and which one is on the bottom. That's it. It's as easy as that. So when you're trying to find the area between two curves, right? The area between two curves is this formula right here. Let me write out this, actually. Yeah, let me write this out for you. If f and g are continuous on the interval a to b, including those endpoints, and g of x is less than or equal to f of x, right, for all x's in the interval a to b, right, then the area of the region bounded by the graphs of f and g is, let's go with it, is going to be equal to the integral from a to b of f of x minus g of x dx. So that's it. If you have one function and another function right there, we have, get that out of the way. We have the way of calculating that said area. Okay. Give you guys a second to copy that down. Good job, Kaylee. Good job. That is exactly it. Subtract one from the other. Like my picture, my picture of my visualization of this problem? I think it's nice. Let's take a look. Let's take a look. Here we go. Let's do an example problem of this. I'll leave that right there so you guys can see that a little bit. Well, if you guys are still writing. Man, I got to work on my writing. I write so much at a diagonal. I don't know if you guys can. Have you guys gotten annoyed by this at all throughout the year as I've been writing? No one just wants to say anything? You guys don't mind? Let's do an example here. Let's say I was asked to find the area of the region bound by, let's see here, the following functions. Let's go with y is equal to x squared plus 2, y is equal to negative x is equal to 0, and x is equal to 1. Can we draw a slope line through it to determine if it's a diagonal? I mean, here, you can just see it. I'll show you. You can clearly see it's not on the lines that I'm writing. Oh, by the way, for you guys going off to college, I highly suggest buying something like a tablet. Like I have a Surface Pro, which is what I'm writing on. It's super convenient, especially if you guys are going off to college. If you're going to do notes, I suggest you do notes like this. It's the way of the future, honestly. You can organize your notes so much easier. This sounds like a plug for the Surface, but you can do it on the iPad as well. If you guys commit some of your money to that for your freshman year, get an iPad or get a Surface, get something that's touchscreen with a digital with a pen for it, and take your notes this way. I'm not even gonna lie to you, like it's just so much more convenient than doing it on pen and paper. Yeah, let's just keep that in mind if you guys are doing that stuff. But anyways, take off these lines. What am I doing? Always create pages with ruled lines. Hey, you could do grid lines. Anyways, go back to none. So anyways, let's take a look here, right, at this problem. I need to find the area of the region bounded by this. In order for us to do this, what makes it easier is always start this off by see if you could sketch it. Sketch the graph. This is how I would start it off every single time. Sketch the graph that you're working with, right? So this right here is going to go through this xy axis like so. Y is equal to x squared plus 2 is a parabola that's shifted up 2. So here we go, up 1, up 2. The vertex of that thing is going to be here, right? And it's going to look like it's something like this, right? This is going to be my y is equal to x squared plus 2. I said 2. I wrote 1. I don't know if anyone saw that. Let's go to the next one. Y is equal to negative x. Let's do that in a different color. Let's do that one in blue, right? Y is equal to negative x. That's going to go through the origin, right? It has a slope of negative x, which means it goes down 1 over 1, and it kind of just goes like this, right? right there. And I say, knock me, I don't see any shaded region that's going to be here. Is it just from here all the way down to here? And I'll say, hold on, be patient. We're not done with the rest of the equations yet. All right, the next one up, x is equal to 0. X is equal to 0 is a vertical line going through the y-axis like that. That's what x is equal to 0 looks like. And then, of course, we have x is equal to 1. And that's another vertical line, but it goes through here and here. Now, when you do this, I actually kind of need to know what this point is and what this point is, but not actually, though, do I? Do you guys see the region that's going to be between all those, that's bounded by all these graphs right here? It has to be bounded by all four, right? And hopefully you guys can see it. It's this region right here. Bam. Now, when I look at this region, it's perfect, Monica. That's exactly it. The region here is bounded from 0 to 1. So when I do my integral is going to be from 0 to 1, right? It's from that 0 to that 1. So I have my bounds to do my integrals. That's awesome. Now I need to figure out which function is the top function, which function is the bottom function, right? Which one is which? Well, clearly this blue line is below this black line right here. So y is equal to x squared plus 2. I think that's going to be the top function, isn't it? This right here is the top function. And I'm going to subtract that from my bottom function. That's it. So all I have to do now is plug in which one goes on top. The one that goes on top is x squared plus 2. And I subtract that from my bottom function. And my bottom function is negative x. This thing, of course, this whole thing is a dx. So it's right there. And that's it. That's how I'm going to calculate the area between two curves on a specific region. And this region goes from 0 to 1. Right? So again, put in this in your notes right here. This right here is the top function, right? This right here is the bottom function. Top, bottom. There you go. And that's it. Now we just do the integral like we've been doing for the whole last couple chapters, right? Check to see if you need to do u substitution on any of these functions. Check to see if you need to do any crazy like manipulations to it. In this case, I could just rewrite this integral. This is from 0 to 1 of x squared plus 2 plus x, it looks like, right? Plus 2 plus x dx. Do this integral real quick. It looks like it's just a power rule. This is going to be x cubed over 3. The plus 2 becomes a plus 2x. The x itself becomes an x squared divided by 2. I did each of these individually. That's all I did, right? Using the power rule in this case. And this whole thing, of course, is going to be evaluated from 0 to 1, so I don't need a plus c for this guy, right? I go ahead and plug in these values here. So I'm going to plug in, it goes from 0 to 1, and I hope you guys can see that when you plug in 0, it's just going to cancel out anyways because it's 0 plus 0 plus 0. So technically, I'm just plugging in for 1. But if you want to see the work, right, it's going to be 1 cubed over 3 plus 2 times 1 plus 1 squared over 2 minus 0 cubed over 3 plus 2 times 0 plus 0 squared over 2. All right, so all these go to 0. This is what I mean. By the way, if you ever know this and you see the 0 there and you see a bunch of these terms, you don't actually have to show this step. That's a bad habit, though. But I was always lazy. I feel like if you can see it, it goes to 0. But again, you could make a common mistake there. So just be careful when you do that. This is going to equal to, we got 1/3 plus 2 plus 1/2. I'll show my work. Minus 0. This is going to equal to, I'm being lazy, but I don't want to be lazy. Can we do this real quick? What is this? 2, common denominator is 6. So it's 2 plus 6 plus 3. No, 6 is 2 is 12. 12 plus 2 plus 3 is 17 over 6. I could be wrong. Oh, thank you, Monica. I could just look over at the chat. You guys have these answers for me. But yeah, that's your answer. Ta-da! The area that's in this shaded region, right? That right there is approximately 17 over 6 units squared. That's it. Not too bad, right? Not too bad. Area between two curves, is it really difficult? I'm hoping you're going to say no. the concept of it is a very easy concept. The actual doing of the integrals can get a little tricky sometimes. But understanding like all you're doing is just taking the integral of the top function minus the bottom function, and that's it. That's all it is. And you'll say, knock me, but you know what used to confuse me when I looked at these problems is, doesn't this look like it's supposed to be negative area? And it is. That's why we subtract it, and it just ends up being giving me this total area of whatever it is that's between the two. It doesn't actually subtract that from the bigger chunk, which I think is kind of neat. You can have area, you can have the function go above or below the x-axis, but if you just subtract the two functions, it'll give you the area that's between them automatically. Automatically. All right, let's do another one. Let's do another one. You know what? I'm too self-conscious. I'm going to type this out this time. Let's see here. Let's go to size 16. Let's type this one out instead. Find the area of the region bounded by the graphs of, I'll type this part out. I'll write this part out. Let's see here. It's bounded by the graphs of f of x, right, equaling to 2 minus x squared, right, and g of x equaling to x. Right there. And then we'll go down here and say sketch the graph and shade the region. So go ahead and do that real quick for these two functions. Can you sketch the graph for me for just these two functions right here and show me what the shaded region should look like? So I'm going to draw this XY axis. Knock me, just do this. Just be a little cheater. Bam. Draw your two functions for me, please. Draw your two functions for me. I'll do the hard one for you. I'm going to go ahead and sketch out the, whoops. Oh, I did not mean to change my axis to blue. I'll do this one for you right here in blue. G of x is equal to x. You ready for this one? This one's a tough one. Right? It goes like that. All right, there's my g of x. You guys got the other one? What's the other one look like? 2 minus x squared. Or in other words, if you want to look at it, it's technically negative x squared plus 2, if you want to look at it that way. It's a frown, that's right, and it's up 2, right? The negative x squared makes it go like a frown, and then the plus 2 shifts it up 2. So it looks something like this. Negative x squared plus 2. You don't have to do this if you don't need to. I like to rewrite it into the form of the parent graph, but it's basically you go up 2, which is here, and it kind of frowns like this, doesn't it? The shaded region is between the two, from here to here. Like so. Now here's my follow-up question. What are these points right here? What is this value and what is this value? I need those values, don't I? That's what's going to tell me how to do my integral. I can already clearly see which function's on top and which function's on bottom, right? Hopefully you guys can see that. It's f of x, right, minus g of x. Hopefully you guys, or actually, do you have any questions on how I know it's f of x minus g of x? All right, it's just based off the graph, right? And I saw that this one's bigger than that one, and I know that this is the case. Now here's my issue though. I don't know what interval I need to put my integral to. How do I figure that out? How do I know what this point is right here and what this point is right here? We could just do plus c. No, we can't. We're not doing that. We're looking for area between the two curves. Plus c is when we're looking for the antiderivative and where it could fit, right? They're not asking us for that this time. But I like that idea. I like the start. I like we could just put a plus c on something that doesn't have those intervals. And that's a good way to go with it. That's a good thing to look at. It's a good habit to have. Just, I don't see any numbers there, put a plus c. But in this particular case, I need the number because I need to know what this area is that's in yellow. Find where the points intersect using system of equations. Yeah, that's pretty much it. Where do these two dots occur? When does f of x equal to g of x, right? When does f of x equal to g of x? Well, lucky for us, we all took algebra, and we can calculate that out. 2 minus x squared, when does that equal to x? And I don't know if you heard me saying this throughout this whole school year, you know, you kind of need your old algebra skills. It doesn't go away. We got to know how to solve this quadratic right here. And how we solve this quadratic, you can do it either by setting equal to 0, you can plug it into a calculator and graph it, you can do ultimately anything you want to do, you just need to get that answer. If this was on a calculator section, you could graph the two functions and then have it plot the intersections, and it'll tell you what those x values are. If you're doing on a non-calculator section, you hopefully are given algebraic expressions, which most of the times they do. They'll give you expressions that you can solve with algebra 1 or algebra 2. In this case, solving this quadratic is from like IM2 in our classes, I believe. Anyways, set it equal to 0. So 0 is equal to, move the x squared over, this becomes positive x squared plus x minus 2, right? This looks like something that is factorable. I'm going to go ahead and try to factor this. I believe this is going to be x plus 2 times x minus 1. You can use whatever method you want to factor this, right? X method if you learned it that way, box method. I do guess and check method, whichever way. Solve this out. You have x plus 2 is equal to 0. In other words, x is equal to negative 2. X minus 1 is equal to 0, which means x is equal to 1. So where are these things occurring at? This thing right here is occurring at x equals to 1. And this one right here is occurring at x equals to negative 2. So the interval that I need to do this on is going to be from negative 2 to 1. And that's it. That's it. Plug that in, and let's plug in our functions being subtracted from each other. So we have here, this is going to be negative 2 to 1 of, you ready? My f of x function is 2 minus x squared. I'm going to be subtracting that from my g of x function, which is x. This whole thing, of course, is with the dx. When you simplify and distribute this negative and get rid of those parentheses, this is going to go from negative 2 to 1 of 2 minus x squared minus x dx. Do that integral just like we've done in the past, right? Piece by piece, little by little. Integral of 2 is going to be 2x. Integral of negative 2x is going to be negative 2x. Integral of negative x squared is going to be negative x cubed over 3 minus the integral of x is going to be x squared, of course, over 2. Again, that's just the power rule being applied there. This is, of course, being evaluated from negative 2 to 1, right? Negative 2 to 1. Plugging this all in, I'm going to end up getting, this is going to be fun, 2 times 1 minus 1 cubed over 3 minus 1 squared over 2 minus 2 times negative 2 minus negative 2 cubed over 3 minus negative 2 squared over 2. So over here on this side, over here, I'm going to end up with 2 minus 1 over 3 minus 1 over 2. Over here, I'm going to end up with negative 4. That's going to become a plus 8 over 3. That's going to become a minus 4 over 2. It is just 2. Do some calculations with fractions and whatnot, combine like terms. If you work this all out, it comes out to like 27 over 6. Right, common denominator 6 here, so that should be common denominator 6 as well. Distribute the negative. I believe it's 27 over 6. This is just me memorizing the answer from before. I think this is right. Someone could double check that for me. It reduces, by the way, and you can reduce this down to 9 over 2. And that's your answer for this one. So the area that's in yellow right there is going to be 9 over 2. Area between two curves. What do you guys think? How do you feel? You feel okay? You feel not okay? Is this a lot? Is this a little? Is this too much? Is this what the heck is going on? What do you think? It's tedious. I agree with you, Brian. It is tedious. Angela's saying, eh. Eh, like what, Angela? Eh, like you don't know what the heck is happening, or it's like, Monica's saying it's okay. You sort of get it. Okay, you sort of get it. Cringe. I don't know how you feel if I can be cringy. I don't know if math can be cringy. Math is just math. Or are you cringing at having to do it? Or are you just cringing in general? Do you cringe when I say the word cringe? Overall strategy when you're doing these problems, right? Graph out the functions that you're dealing with. It's not that bad though. Yeah, overall strategy, honestly. Graph out the functions that you have and see if you can find the region that is being bounded. Then try to see on the intervals that they're on, like what your a is and what your b is, and then just do the integral from a to b of your top function minus your bottom function. That's all there is to it. You're just looking for the top function minus the bottom function. Okay? Which one's on top, which one's on bottom? Now, if they alternate on the interval, so for example, I'm just going to draw this one out here. Let's say I had a function that did this, and I had a function that did something like that, for example, and let's call that f of x. And then I had another function, let's say it did something like this instead. It goes like this, right? And we'll call that g of x. And in a problem, they'll ask us to find the region that's bounded between the two here and here. Okay? If this ever comes across you, right, notice that your top function and your bottom function switches at a point. So let's call this here from A. Let's call this point right here B. Let's call this point right here C. So I can't just do the integral from A to C, right? Because the top function and the bottom function changes in the middle. So what I have to do instead is I have to calculate this part first from A to B. And that's because from A to B, the top function is f of x, right? Minus g of x. And then what I'm going to do now is add the integral from B to C. And if you look, from B to C, the top function is no longer f of x. The top function has become g of x minus f of x. And this will happen at times. You need to pay attention to how many times your function switches from top to bottom. And you have to figure out which one is the top function, which one's the bottom function for the specific intervals that you're working with. Okay? Pay attention to those things. It does matter, and it does affect the problems that you're dealing with. Okay? But yeah. Just keep that in mind. Pay attention when a function switches from which one's top, which one's bottom. Sometimes they don't even switch. Sometimes they do some weird stuff like, I've seen problems where they draw out a function, and one function does this, another function does this, right? And you think that this is the area you need to find, and then they throw a monkey wrench in there and they say, ah, just kidding, there's also a third function that does this, give me this area. I kid you not, this happens. So in this particular case, you don't need to do one function minus another function. I don't know if you guys can see this or not. But at this region right here, I just need to do the integral of this function. Let's call it f of x, right? So I just do this from 0 to a, right? And then from a to, let's say this one over here is called b, right here. From a to b to get this area, right? I would just do the integral from a to b of this blue function. Let's call that g of x. And then the last one right here, to get this one over here, I would just go from b to whatever this point is. Let's call that c. So this one right here, it looks like it would be a subtraction of functions, but it's actually not. This one, you just break it down like, oh, this is the integral from 0 to a of f of x, right? Plus, then you do the integral from a to b of g of x, right? And then plus the last one is the integral from b to c of, I don't know, let's call that h of x. You're not even subtracting top and bottom because there's no functions that are top and bottom in this case, right? So keep that in mind. Keep that in mind. That happens. That is a thing that they'll try to trick you with. You have to pay attention to which function's on top, which one's on bottom. But in this particular case, there's no top and bottom. It's just top. And what's on what's on top of the x-axis, right? So that's it right there. So just keep that in mind. They'll throw these kind of problems at you. I'll try to get some of these problems for you to practice today on your homework. By the way, homework, when I assign these next couple of homework assignments, they're there just for you to practice. You don't have to complete them and turn them in right away. I'll take them late. I'm just trying to get you guys ready and good to go. Why is my stuff not syncing? All right, anyways, that's that, okay? Now, this is area between two curves when we're looking at it on the x-axis. Sometimes they like to mix things up, and this gets tested for your exam as well. So just write, this will be the next title here. Let's go, let's make this, since this is the title, let's make it a little bigger here. Let's make it 22. Sometimes they'll ask you to find areas between curves expressed as functions of y. So let's take a look at this one. All right, there we go. So what does that mean when a function is expressed in terms of y? It's basically, instead of it going up and down, if it's expressed in terms of y, your functions are now horizontal. They go sideways now. And it'll look something like this. I don't know why, but I've become self-conscious about my typing, so I'm going to start typing this out. Find the area of the region bounded by the graphs of, and here they are. Let's go with x equals to 3 minus y squared and x equals y plus 1. Oh, thank you, Monica. You're too kind. I don't know why I got conscious about it, so now I'm typing, but I appreciate that. Okay, so here's the thing. You can do this in two ways, right? You can convert this to in terms of x's, but if you do that, if you solve for y, you're going to get a plus or minus here, and you have to graph the plus or minus. And some of you guys are okay with that, some of you are not. Another way is leaving in this term and just dealing with it as it is. So for example, this one is actually not that hard to graph, right? X is equal to y plus 1. If you want to, you could rewrite this as y is equal to x minus 1, which means that it's going to be a line that's doing something like this. It has a slope of 1 over 1, so it's going to look something like this. Now, if you're having trouble seeing that in this term, I think one way of that can help is just plug in some numbers for y and see what comes out for x. So if you plugged in 0 for y, x would be 1, right? So 0 for y, x equals, yeah, 0 for y, x equals to 1 would be this point right here. If you plug in 0 for x, you'll get y is equal to negative 1, and that gives you this point. And that's a linear function that just graphs out your line. When you get to something more complex like this the squared function, you have a couple options here. You can try to see the connection if it were written the other way, if it was y is equal to 3 minus x squared. Hopefully, if you have this in your repertoire, right, this is a frowny parabola because it's a negative and it shifts up by 3, you know that it should look something like this at 3, right, on the positive y-axis, and here's my x-axis. Now, the way that switches up when you have x equals, it's the same concept, except now the plus 3 is 1, 2, 3 this way, and the frowny part that's going on the negative part of your x-axis instead. You see here it goes negative on the y-axis here with this frowny part. Instead, here it's just going to do something like this. It's just going to go frowny this way. Now, if you have trouble doing that, if you have trouble visualizing that, for now, I honestly, we don't have enough time to go through graphing things that are in terms of y. But for now, if you need help just doing it on this on your homework and getting used to this, I suggest using Desmos for now. Plugging this into Desmos and seeing what that graph should look like, and then copy that graph. And hopefully, doing that, you won't be able to do that on your TI calculator yet. But for now, like hopefully, just it helps you to see it. You know, so I would go to Desmos here, plug in this equation, x equals to 3 minus y squared. See that? And it'll graph it for us. Okay, just to help us getting used to this. All right. Same thing with the other function. X equals to y plus 1. If you're having trouble seeing it, that's what we can do there to help us to see it. Okay. So not only that, though, Desmos also helps you to see where they intersect. If you want to take a look, right, that's going to cross there, and that's going to cross there. Now, here's the thing, though. If we're doing it in terms of y, I don't take the x values for my integral, right? I don't take the x values for my integral. I'm going to just screenshot this for right now and take this with us over here. So let's go ahead and put this over here. Oh, I got the color swapped. That's fine. Okay, so got my color swapped there. So here's the deal. Let's switch the colors back around there. Let's go with this one being blue, this one being red. For this area here, right? Here's the thing. It's not going to be the integral from -1 to 2. That would be the case if I was going this way. But I don't have, like, if you do it this way, the top function would be blue, right, to the bottom function red up until this point, and then after that, I have to do this area. That's actually a little annoying to do. It's honestly a little bit annoying to do, because then you got to do like the square root function, you got to do the integral of the square root, and it gets really, really messy. So instead of doing that, what you can do instead is look at it from the y value. So you kind of go from -2, right, all the way to 1. So can you guys see it? -2 right here to 1. I'm going to do the intervals this way and get this area like that. And if that's the case, this one in red right here, this will be my, quote, top function. I'm tilting my head. I don't know if you guys can see that, what I'm essentially doing here, right? And then that blue one will be my, quote, bottom function, right? Here, let me see if I can paste. Check this out. What I'm essentially asking you to do is can I rotate this? See that? So I'm asking you to do it this way, and I'm asking you to do the integral from, right, again, let's write this out. This one is my, quote, top function. This one is my, quote, bottom function. Right? Like this. I'm hoping you guys can see that. And then the integral that you're doing it from is from this point here to this point here, which is like kind of mirrored, right? So when we do this integral, this is going to be the integral from -2 to +1, not -1 to 2. You guys see it? It's a little weird. I know, it's a little strange. But the reason is, if I do it in terms of the y function that I already have with respect to y, the integral is a lot easier than doing it with respect to x. Because with respect to x, I got to like solve this for y and then get the plus or minus, and I have to do the integral of a square root. And it just gets a little messy. Whereas this one's already written out like this. Check this out. You ready? The top function is the red one, right? So that's going to be this function right here, 3 minus y squared. The bottom function, right, is going to be this one right here, y plus 1. This whole thing, if I do this integral, I'm no longer doing this integral with respect to x. I'm doing this integral with respect to y. So that's it. When I rewrite it this way, I can still do my power rules and do all my other stuff and do this integral with ease. Now, it just takes a little bit of your brain getting used to the fact that you're not writing x's now, you're just writing y's. But check this out. If I do this, right, if I do this, this becomes the integral from -2 to 1 of, hear me out now, this is going to be, without these things right here, let's simplify this out. This is 3 minus 1, which is going to give me 2. Let me just show the work, knock me. 3 minus y squared minus y minus 1 dy, which of course simplifies out to -2 to 1. And I have here negative y squared minus y plus 2 dy. And what I'm saying is this, right? This integral, I know it's annoying with the y, but I'm telling you, you just do this integral like you would with the power rule here. This is going to become negative y cubed over 3 minus y squared over 2 plus 2y, and then you're going to evaluate this from -2 to 1. And what this right here represents is this area going on the y-axis instead. See that? And you can do that if the function is written in as functions of y instead of functions of x. It's the same thing. It's just your head's supposed to be rotated and flipped around just to see it. It's the same concept of top minus bottom, but top is a little bit different. And hopefully you guys can see why this is considered top, because the numbers are more positive in this sense, right? The x values goes to 3, and then the other way is negative, just like we did for the when we look at it as a function of x. Okay. Anyways, let me finish off this problem, and let me plug in these values here for us to get these numbers here. So I'm going to have here negative 1 cubed over 3 minus 1 squared over 2 plus 2 times 1 minus, do this big thing over here. This is going to be negative 2 cubed over 3 minus negative 2 squared over 2 plus 2 times negative 2. All right, and then do the calculation, evaluate all this. This is going to come out as negative 1 over 3 minus 1 over 2 plus 2 minus 8 over 3 minus 4 over 2, which is 2, minus 2, let's do this is minus 4. So you combine all that together, and this is going to come out to be like something over 6, some large number. It comes out as, I believe it comes out as 9 over 2, I believe. But that right there is your answer to that area up there. Hopefully you guys can see that. I'm going to zoom in a little bit so you guys can see this first, so you can write that down. But again, the integral steps of this, right, is nothing new. It's the same concept, except now instead of x's, they're y's. And you just have to get your mind to wrap around the fact, like, okay, it's not going from, and this is the part I need to bring up, it's not going from negative 1 to 2, right? Instead, it's going from negative 2 to 1. It's the flipped around version of it, right? I'm looking at it from the y aspects of it as a function of y, as opposed to a function of x, right? We would normally deal things with functions of x, and we have a top and a bottom. But if you take that top and bottom and just go this way, right, you can see which one's top, which one's bottom, and you can see your x, your integral values that you need to put in there, okay, from what to what that it needs to go to. Woo. So that's area between two curves in a nutshell, right? I'm gonna put the homework up today just so you guys can try a couple of these problems. Again, don't worry about finishing them in and submitting them before like the due date. The due date is just a random due date I'm gonna put on there. It's more for you to practice. I want you to practice this. I want you to, as well as start your review for your AP exam, right? Doing all the stuff that you need to do to review. You could be watching those review videos. You could be doing Calc Medic reviews. You can be doing Khan Academy review. You could be doing the review from the book that hopefully you picked up from the school, which is apparently yours, and you should do that because it's free, so you don't have to pay 20 bucks at Barnes & Noble or some other place to buy that review book. It is something that you should get. And yeah, we're pretty much at the crunch time. We got, I'm not gonna lie to you. Let's see here. We got about 1, 2, 3 more topics to cover before the AP exam, and we only have like 4 more full-on meetings, so it's cutting it kind of close. So you guys need to start doing your reviews, and if you need help doing some reviews, legit, come to tutoring, come to office hours. This is the time to see if you're, ready or not. Chances are you are going to need some help, and I will be there for you, okay? Stop by for my office hours, like I said, from 2 to 3, or stop by on campus from 3 to 5 if you need some place to study. I'm not going to, from 3 to 5, I don't know, you can ask the other people who showed up. It's very, very relaxed. I'm not sitting there and like, hey, do these problems by the end of the time that you're here. Honestly, I want you to stop by because, yeah, we'll just figure that out. Anyways, that's it for me today. Get started on that stuff. Get started on the homework I'll post it later, and then get started on your review. Other than that, have a good rest of your day. Have a good rest of your week. I won't see you guys until Monday, okay? Have a good weekend, everybody. Stay out of trouble. Stay out of jail. Don't get pregnant. Bye, everybody. So long. Farewell. Bye, Leslie. Bye, Emily. Bye, Monica. Bye, Angela. Bye, Joe. See y'all later. Bye, Diana.